In this video, we're going to talk about hyperbolas, and this is designed to be a complete guide for you. So we're going to be talking about how to graph hyperbolas, how to write the equations, how to find the vertices, foci, eccentricity, the asymptotes, how to write it in the standard form of the equation of a hyperbola. So 8 examples that we're going to go through, and we're going to talk about what exactly is a hyperbola. So let's dive in. So hyperbola, it kind of looks like two parabolas facing opposite directions. It could either go like this or it could go like this. But more precisely speaking, what it is, it's the set of all points such that the distance from this point to this focus minus the distance from this point to this focus is always a constant, and we call that constant 2a. Now, you'll notice that as you go further and further out on the hyperbola, the distance from this point to this focus gets longer, but so does the distance from this point to this focus also gets longer. When you subtract those two distances, it's always equal to that constant of 2a. And so you can think of it as PF1 minus PF2 equals 2a. Now you might be saying, Mario, what is this 2a? Well, a is the distance from the center to the vertex. So your vertex is where the hyperbola bends. That distance is a. Again, the distance from this center to this other vertex, that's a. So the distance between the two vertices, that distance is 2a. That's always a constant. Now, we can write the hyperbola in this form: x minus h squared over a squared minus y minus k squared over b squared equals 1. Notice when the x squared term is first or positive, that tells us that the hyperbola is going to be opening horizontally, or left and right, or what I like to say, the x direction. More precisely, it's referred to as having a horizontal transverse axis. So this axis here that the vertices are on is horizontal. Okay, that's the transverse axis. Now, if the y squared term comes first, then it's going to be opening in what I like to say the y direction, or the vertical direction, and this would have a vertical transverse axis. Okay. Now, we're going to be talking about what A, B, and C represent as we go through some of the examples. We've already talked about how A is the distance from the center to the vertex. C is the distance from the center to the focus, and then B, we're going to talk about how it plays into when we find the equations of the asymptotes. But there's this formula, c squared equals a squared plus b squared, that ties all those quantities together. Let's look at our first example, and I think you'll get a feel for how this works. We've got this equation, x squared over 4 minus y squared over 9 equals 1. Notice there's not an h or k value grouped with the x and the y. That tells us that the center of this hyperbola is going to be right at the origin, or 0, 0. So let's just label that. Notice the x squared term comes first. That tells us it's going to be opening horizontally in the x direction. And what we do is we take this number here, 4, we're going to go in the x direction, the square root of 4, which is going to be at 2, 0, that's our vertex, and negative 2, 0, that's our other vertex. With this other value, 9, we're going to go in the y direction, up 3, okay, and down 3. And what we do is we draw a dashed or dotted rectangle through those points, and we use the corners of this rectangle and the center to draw our asymptotes. Now remember, asymptotes, I'm sure you learned this in graphing other types of equations, the graph gets closer and closer to those asymptotes without touching or crossing. It just kind of approaches them like that. And so it gives us an idea about how wide or how narrow this hyperbola is. So let's go ahead and label what we have so far. We have the vertices, which are at 2, 0 and negative 2, 0. We want to find our foci. So where are our foci? Our foci, they're the distance between the center, okay, they're along the same axis, I should say, as the vertices. That's our transverse axis. And we use this formula, c squared is equal to a squared plus b squared, just like the Pythagorean theorem. So that comes out to, let's see, c squared is equal to a squared, which is 4, plus b squared, which is 9. So c squared is 13. Take the square root. C is equal to plus or minus the square root of 13. So from the center, we're going to be going left and right, square root of 13. So our foci are at plus or minus root 13, 0. Root 13 is somewhere between 3 and 4, maybe about 3.5 or so. So it'd be somewhere right around here. Okay, roughly, if you want to get a sketch. Now, the equations of the asymptotes, you can do a couple things. You could Think about the rise over the run, like we're going rise 3, run 2. That gives us a slope of 3/2, so we could say y equals 3/2 x. The y-intercept is 0, so there's not a b value. We can also see that you can go down 3 over 2, so the other one is going to be negative 3/2, so we could say y equals plus or minus 3/2 x. Those are the equations of our asymptotes. One thing I like to tell students is that the number underneath the y is like the rise, and the number underneath the x is like the run, and we know that our slope is like the rise over the run. Just remember to take the square root of these values, so 3 over 2, there's our slope. Now, when it comes to when the graph is shifted, we have a center that's not at the origin, we're going to talk about the point slope form of the equation of a line, and we'll deal with that in some of the other examples coming up. Let's take a look at another example. Okay, for example number 2, we're going to graph this one, y squared over 1 minus x squared over 4 equals 1. And what you'll notice about this one that's different from the first example is that the y squared term is coming first, or is positive, which tells us that this hyperbola is opening in the y direction, like up and down. So what we're going to do now is we're going to see again that the h and k is 0 and 0. It hasn't been shifted, so our center is going to be right here at the origin. And we can see that in the y direction, we're going to be going up and down 1. So up 1, down 1. That's where our vertices are located at, so 0, 1, and 0, negative 1. The 4, we're going to go the square root of 4, 2 in the x direction, plus or minus 2. And remember, we're going to draw that rectangle, that dashed or dotted box, through those points. We're going to use the corners of the rectangle and the center point to draw our asymptotes. That gives us an idea about how wide or how narrow our hyperbola is. Again, keep in mind, sometimes when you draw these points, students will mistakenly see the points and draw it like in this horizontal direction. But remember, this is a y squared type, meaning the y squared term is the positive term. It comes first. That tells us it's going to be opening in the y direction. So it's going to look like that. Now, another mistake sometimes students make, and you can see I'm probably making it right now, is you don't want it to bend away from the asymptotes. You want it to gradually get closer and closer to those asymptotes. Again, it gives us an idea how wide or how narrow this hyperbola is. Now, notice that the foci are always on the transverse axis, that same axis that the vertices are on, where the hyperbola bends. And to find those foci, we use this formula, c squared equals a squared plus b squared, just like the Pythagorean theorem. In this case, a squared is 1, b squared is 4, which means that c squared is equal to 5, and c equals plus or minus square root of 5. So what we're going to do is we're going to go from the center up root 5 and down root 5. So it's going to be 0 plus or minus square root of 5. Square root of 5 is about 2.2 roughly, so it'd be somewhere around here and here are our foci. And one thing we didn't talk about in the last example is the eccentricity. Let's talk about that for a minute, and then we're going to also do the equations of the asymptotes. But the eccentricity, it's defined as c over a. C we figured out is square root of 5. You can just take the positive quantity. A is square root of 1, which is 1. And this is our eccentricity. Now, the eccentricity for hyperbolas is always going to be greater than 1. For ellipses, if you learn about ellipses, it's between 0 and 1. But for hyperbolas, it's greater than 1. And the closer that it gets to 1, okay, the closer to 1, the wider these branches of the hyperbola are. They start to get, if it's almost 1, it's almost kind of like two parallel lines, right? And the larger that it gets, you know, the eccentricity, the kind of like the more compressed or narrow these branches of the hyperbola are. So that's kind of what the eccentricity gives us an indication of. You know, it's the shape. But let's talk about the asymptotes now. Now the asymptotes, you can either, once you have the graph, count the rise over run. So like rise 1, run 2, that's a slope of a half. So y equals 1/2 x plus b, but the b is 0, it goes right through the origin. And y equals down 1 over 2, so negative 1/2 x plus 0. You can also use the numbers underneath the y and the x in the equation. Remember, the number underneath the y is the rise, the number underneath x is the run. Just make sure to take the square root. So 1 over 2, see, rise over run, 1/2. Let's take a look at another example. For example number 3 now, we've got x plus 3 squared over 9 minus the quantity y minus 1 squared over 16 equals 1. Remember, with hyperbolas, it's always subtraction. With ellipses, you'll see that this is addition. But the key thing with hyperbolas is whichever term is the positive term, that determines whether it's opening horizontally or vertically. In this case, you can see the x squared term is the first term of the positive term, so that tells us it's going to be opening in the x direction or the horizontal direction. The other thing that's different between ellipses and hyperbolas is that with hyperbolas, the a squared is always underneath this positive term or this first term, whereas with ellipses, it's always going to be the larger denominator. So sometimes students get confused. They think, oh, this is larger, this is my a squared. That's only for ellipses when you're adding. Hyperbolas, a squared is underneath this positive term. Now notice this one, we have an h and a k value. That means that our center is being shifted. So the center here is going to be at -3, +1. Remember, it's always the opposite from these signs. So we're going to go left 3, up 1. There's our center. Again, we said it's opening in the horizontal direction, or it has a horizontal transverse axis. The square root of 9 is going to be 3. So from the center, 1, 2, 3. There's one of our vertices. 1, 2, 3. There's our other vertex. Let's put the coordinates of those vertices. That's going to be at 0, 1, and -6, 1. And then let's see, so what else do we have here? We've got 16, square root of 16 is 4, so from the center I'm going to go up 4 and down 4. We're going to use these points to draw that dashed or dotted rectangle, which remember we use that as a guide by using the opposite corners of that rectangle and the center point for drawing our asymptotes. Okay, remember those are dashed or dotted lines. And let's go ahead and, before we write the equations of the asymptote, let's find the foci. The foci, remember we use this formula, c squared equals a squared plus b squared. C is the distance from the center to the foci, which we don't know, but we know that a squared is 9 and b squared is 16, so c squared equals 25, which means that c equals plus or minus 5. So from the center, I'm going to be going left and right 5. So that's going to be -3 minus 5 would be -8, 1, and -3 plus 5 would be 2, 1. So that would be right here is our focus, and -8, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 1. There's our other focus. For the equations of the asymptotes now, we're going to use our point slope form of the equational line. Remember, this is a y minus y1 equals m times x minus x1. Because it goes through the center, that's like our x1 and y1. So it's going to be y minus the y coordinate of the center and x minus the x coordinate of the center. Those two negatives cancel. The slope is the rise over the run, or you can do the number underneath the y divided by the number underneath the x. This would be 4 over 3. We want to take the square root. And it's plus or minus. This one has a positive 4/3 slope. This one has a negative 4/3 slope. You could leave it like this. It depends on your teacher, your class, or what you're trying to accomplish. But let's go ahead and see if we can solve for y. So what I'm going to do is I'm going to take the positive one first. So I'm going to say y minus 1, distribute the 4/3. So that comes out to 4/3 x plus 12/3, which is 4. Add the 1 to the other side. So we have y equals 4/3 x plus 5. That's one of our asymptotes. Now let's take the negative one. Y minus 1 equals distribute the negative 4/3. And that gives us a negative 12/3, which is -4. Add the 1 to both sides. That gives us a negative 4/3 x minus 3. And let's see, you can see it's crossing here at -3, and it's crossing here at positive 5. Those are our equations of our asymptotes. And the only thing we have to do now is graph it, which remember, it starts at the vertices. Sometimes students make a mistake and draw it through the foci. Goes through the vertices here, approaches those asymptotes. And that's the graph of our hyperbola. Let's take a look at another example. Okay, if you're starting to get the hang of this, see if you can do number 4 on your own, and we'll go through it together. Notice we've got this y squared type, what I like to call the y squared type. This is the positive term. That tells us it's going to be opening in the y direction, or the vertical direction. Has that vertical transverse axis. Notice that the center here now is at 2, -2. So right 2, down 2. This mistake that students sometimes make is they are used to reading from left to right, so they'll say, oh, it's -2, +2. But remember, the one group with the x is going to be the x coordinate of the center, the one group with the y is going to be the y coordinate of the center. It's just that the signs are going to be opposites. Okay, now square root of 4 is 2, so from that center I'm going to go up 2, there's a vertex. I'm going to go down 2, there's our other vertex. Let's label the coordinates of our vertices. That's going to be at 2, 0, and 2, negative 4. In the x direction, we're going to go right 5 and left 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. We're going to use those points to draw that rectangle, which we use that rectangle to draw our asymptotes through the corner, through the center, through the opposite corner. And it gives us an idea about how wide or narrow our hyperbola is. So you can see this hyperbola is going to be kind of wide in this case, right? And let's go ahead and find our foci. Remember our foci, we use this equation, c squared equals a squared plus b squared, just like Pythagorean theorem. And a squared is 4, b squared is 25. So c squared is going to equal 29, and c is going to equal plus or minus the square root of 29. So when we find our foci, they're going to be on that same transverse axis, that same axis that the vertices are on. So from the center, since we're going up and down, I'm going to add and subtract square root of 29 from the y-coordinate of the center. So negative 2 plus or minus square root of 29 is where our foci are located. Now the equations of the asymptotes, again, it's a little bit trickier because the center is not at the origin. We can use our point slope form of the equation of a line. Remember, that's the y minus y1 equals m times x minus x1. The asymptotes always go through that center point, so we're going to use that as a guide here. We're going to say y minus negative 2, which is y plus 2, x minus 2, and then our slope is going to be the rise over the run, or you can take the number underneath the y, which is the rise, the number underneath the x is the run. Make sure to take the square root. That's going to be 2/5 plus or minus. Now, you can rearrange this equation and solve for y and put it into slope-intercept form, y equals mx plus b. Sometimes teachers will just let you move the 2 over and write it like this, plus or minus 2/5 x minus 2 minus 2. But if you want to take it one step further, just write it as 2 separate equations, one with a plus, one with a minus, distribute the 2/5 or negative 2/5, combine like terms, etc. So let's take a look at another example. Example number 5, we're going to write this hyperbola in the standard form of the equation of a hyperbola, and then we're going to graph it. So the first thing we want to do is we want to group the x's together, the y's together, and move the constant to the other side of the equation. So let's go ahead and do that. So we've got 4x squared minus 24x minus 5y squared plus 40y. Add the 64 over to the right side, that equals a positive 64. Now notice, a little tip here, I put the x squareds first because that coefficient was positive, and I put the y squareds, the y second because that coefficient was negative. Because remember, we're going to have x squared minus y squared, or y squared minus x squared. In this case, it's going to be like an x squared type. The next thing we want to do is we want to factor out that leading coefficient. So I'm going to factor out the 4 from the x's, factor out the negative 5 from the y's, and you don't want to factor out the greatest common factor, just the coefficient in front of the squared term. Now we're going to complete the square. So you take half of this b value and you square it. You can think of it as b divided by 2, the quantity squared. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Out of thin air, I'm actually adding 4 times 9, 36 to the left side of the equation. So to keep it balanced, let's add 36 to the right side. Over here, half of negative 8 is negative 4. Negative 4 squared is 16, but it's actually negative 5 times 16, which is negative 80. So we have to add a negative 80 to the other side to keep it balanced, right? Now we're going to factor this, and it's going to be a binomial squared. So this comes out to 100 minus 80, which is 20. And when you factor this perfect square, it's going to come out to x minus 3 squared. It's always half of this b value. If this was plus 6x, it would be plus 3. And the same thing here, half of negative 8 is negative 4. If it was plus 8y, it'd be plus 4. But remember, hyperbolas, and ellipses for that matter, you always want to equal 1, so we're going to divide everything by 20, left and right sides, to keep this equation balanced, and we're going to reduce. 4 goes in here once, 4 goes in here 5 times, 5 goes in here once, 5 goes in here 4 times. This equals 1. So now we have our equation, in the standard form of a hyperbola. Okay, now if we want to graph it or get a sketch of this, let's go ahead and do that. We want to locate the center point, which we can see is at +3, +4. Right about there, center. We can see it's an x squared type, so it's going to be opening in the x direction, left and right. We're going to go square root of 5. Let's write down the center first. So center is 3, 4. We're going to go square root of 5 left and right from the center. So square root of 5 is about 2.2. Okay, so right about here is our vertex, and then left 2.2 is right about here. And if we wanted to be more precise about this, because we're going square root of 5 left and right from the center, that's affecting the x values. We're going to add and subtract square root of 5 from the x coordinate of the center. And then for the 4, we're going to go up and down 2. Okay, and again, remember we use this to draw this rectangle, this dashed or dotted box here, where we use the corners of that rectangle, the center, and the opposite corner to draw our asymptotes to give us an idea about how wide this hyperbola is. Okay, and then we can find the foci. Remember we use that equations, c squared is equal to a squared plus b squared. That's going to be, in this case, let's see, that's going to be 5 plus 4, which is 9. Take the square root, so c is equal to plus or minus 3 from the center. So here's our center. So our foci is going to be at 6, 4, and 0, 4. Just adding and subtracting 3 from the x coordinate of the center. There's our foci. There's our other foci. And then if we want to find the equations of the asymptotes, which I think this tends to be the most difficult thing for students, and this is because there's a little bit more to it, we have to use our point slope form of the equation of a line. It's going to be y minus the y coordinate of the center equals x minus the x coordinate of the center. The slope is rise over run. In this case, it's going to be 2 over square root of 5, so plus or minus 2 over root 5. You can rationalize this if you want. And then you can also divide it into 2 separate equations, one with a positive slope, one with a negative slope, and rewrite it in slope-intercept form, y equals mx plus b. I think for this problem, I'll just leave it like that. The main thing was getting the equation in the standard form. Let's try another example like this, and we'll do one more of these. See if you can get this one in the standard form of the equation of a hyperbola, and you can graph it if you'd like, but I think you're getting better at the graphing, so let's just practice putting this in the standard form. So what I notice is that the y squared term is positive. So I'm going to put the y's first and the x's second. So this would look like 4y squared minus 48y minus 25x squared. Subtract the 44 to the other side. Get the constant out of the way. Then we factor out the leading coefficient here. So this would be 4y squared minus 12y. Leave a little room for completing the square. Minus 25x squared equals negative 44. To complete the square, we take half of b and we square it. So half of negative 12 is negative 6. Negative 6 squared is positive 36. But it's actually 4 times 36, which is 144. So we have to add that 144 to the other side of the equation to keep it balanced, right? Now we're going to factor this. And remember, it's always going to factor to half of this middle b value. So if this is plus 12y, it'd be plus 6. So it's minus 12y minus 6. Negative 44 plus 144 is 100. We always want hyperbolas to equal 1. So let's divide everything by 100. Reduce. And now it looks like we have it in the standard form of the equation of a hyperbola. You can see that this is a y squared type, so it's going to open in the vertical direction, up and down. And you can see that the center is going to be at 0, 6. Remember, the h is with the x and the k is with the y. And you know how to graph it from there. So now let's look at 2 more examples, a little bit different examples. Let's do those next. Okay, for number 7, we're given the vertices of the hyperbola and the foci of the hyperbola, and we want to write the equation of this hyperbola in standard form. The first thing I like to do is draw a little sketch to kind of help me get a feel for, what this hyperbola looks like so that we can write the equation. So it looks like the vertices are at 3, negative 2 right here, and 7, negative 2, 4, 5, 6, 7, negative 2 right about there, Foci are at 1, -2, and 9, -2. So that tells us that this hyperbola is basically looking like this. It's basically opening in that horizontal direction, which tells us that it's going to be like an x squared type. The x squared is going to be the positive term or the one that comes first. Now the center, remember, is always halfway between the vertices or halfway between the foci. We can do the midpoint formula by adding these x's together and dividing by 2 and adding the y's together divided by 2, which would give us 10 over 2, which is 5, and -4 over 2, which is -2. So now it looks like we're getting x minus 5 squared minus y plus 2 squared is equal to 1. Okay, so you can see how I'm doing this. I kind of do a little bit with the graph, a little bit with the equation. I kind of try to piece it together a little bit by little bit. Now remember, the distance from the center to the vertex, that distance is a. So from 5, -2 to 3, -2, that's 2. So you can see that our a value is equal to 2. Our c value is the distance from the center to the focus, so that's going to be a distance of 4. And our b value is, we can find by using the Pythagorean theorem here, c squared equals a squared plus b squared. So that comes out to 16. 2 squared is 4. Subtract 4 from both sides, and you can see that b squared is equal to 12. So here you can see this is going to be 4. That's 2 squared, and then b squared is going to be 12, and that's it. That's the standard form of the equation of our hyperbola. Again, now sometimes students get a little bit confused about the a squared and the b squared. Remember, because this is opening in the horizontal direction, we know that our a squared comes underneath this positive term here, this first term, and the b squared is going to be the other denominator. And a is the distance from the center to the vertex, that's 2, so 2 squared is 4, and we showed how to solve for b squared. Let's take a look at one last example. See if you can do this last example on your own if you're getting the hang of it. We're going to write the standard form of the equation of a hyperbola given the vertices and these asymptotes, and we'll go through it together. While you're starting that problem, I just want to let you know that I have 2 courses for sale. I've got an Algebra 1 and Algebra 2 video course for sale. I've got links in the description, so if you want to review those courses or practice those concepts more. Also, I've got more videos like this on conic sections, on parabolas, hyperbolas, ellipses, circles, and I've got over 1,000 videos now on my Mario's Math Tutoring YouTube channel, so it's, you can check out whatever you're looking for over there. And lastly, let's just jump into this problem, see if we can solve it. So let's see, so we've got our vertices. I like to kind of graph to get a visual on what we've got going on here. So we've got 1, 0 and 1, 6. Okay, those are our 2 vertices. And we know that the center is halfway between the vertices, so that's going to be right here at 1, 3. You can also average the x's and average the y's, but our center is going to be at 1, 3. And we can see that it's going to be opening in this vertical direction, so it's going to be looking something like this roughly. Okay, so which means that it's going to be like a y squared type. The y's are going to come first. So it's going to look like y minus the y coordinate of the center squared minus x minus the x coordinate squared equals 1. Remember, ellipses and hyperbolas are always equal to 1. The distance from the center to the vertex, that's our a value, 1, 2, 3. So 3 squared is 9. Remember, this is a squared. We just need to find our b squared. Now remember, the asymptotes, the slope is the rise over the run. The number underneath the y is going to be the rise. The number underneath the run is going to be the x. So you can see we have 3 over b is equal to our slope, which is 3/2. And you can see here that b must be equal to 2. So this is going to be b squared, or 4. So that's our standard form of the equation of a hyperbola. Great job if you're able to follow these 8 examples. Again, if you want more practice, I'll put a more comprehensive video I did there going through all the different types of conic sections, parabolas, ellipses, hyperbolas, circles. Follow me over to that video for more practice. I'll see you there.